All right, I want to do some examples from section 2-3, which is rate of change and slope. So these are in your textbook. You might want to copy these down so you have some additional examples. And what we're asked to do is find the rate of change for each set of data. So rate of change is the same as slope. And we have this formula to find the slope. We're taking y2 minus y1 over x2 minus x1, or sometimes it's just given as the change, like delta y over delta x, which represents the change in y over the change in x. Or you might have heard of it as rise over run. So lots of different ways to think about it. So when you look at this chart, I'm going to actually use, because you have choices to make, I'm going to use the first ordered pair. These would be the x values, these would be the y values, and I'm going to use the last ordered pair to find the rate of change. So for number 1, when I want to find the rate of change, which is the same as the slope, then I'm going to take the change in y, so I'm going to take 60 minus 12, and in the denominator I'm going to take 10 minus 2. And when I do that, I'm going to end up with 48 over 8, which simplifies to 6. Now, because I have units, I need to pay attention to that. My y values were on the top, they were in feet, and my x values that were in the bottom were in minutes. So when I get my answer of 6, I should say 6 feet per minute. That's the rate of change. Now, if I were doing function notation for this, I would do distance as a function of time. Now, if you instead had put the 12 minus 60 on the top, and you put 2 minus 10 on the bottom, you would find that you still get 6. You'll have a negative 48 over negative 8, so it would still work. Now, what you can't do is you can't put the 60 minus 12. If you start with the 60 in the numerator, then you have to start with the 10 in the denominator. So just pay attention to that. On number 2, I'm going to do the same thing that I did on, actually I'll do a different color here. So I'm going to use the first point and the last point. So when I want to find the rate of change, I'm going to take the change in y, so 80 minus 16, and I'm going to go ahead and put the units so I don't forget them later, cubic centimeters. And then I'm going to have 25 minus 5, and that's in seconds. So when I evaluate this, I'm going to get a 64 over 20. And if I wanted to, I can leave it as a fraction if I want to. If I do that, I get 16/5. And this would be centimeters cubed per second. But when you're dealing with word problem, it's not really a word problem, but it's a real life situation. A lot of, what's the rate of change of the volume? 16/5. A lot of times you wouldn't leave your answer like that when you were reporting your answer. So if you were to change that to a decimal, this would be one where it'd be okay to say 3.2 centimeters cubed per second, and that would be the rate of change. So on this next one, they're comparing digital cameras to film cameras. So the graph shows the number of digital still cameras and film cameras sold by yellow camera stores in recent years. Part A asks us to find the average rate of change of the number of digital cameras sold from 2004 to 2009. So I'm going to find 2004, and looks like for the digital it's 20. Be careful because it's 20,000. So in 2004, there were 20,000 cameras sold. So I'm going to write that down as one of my ordered pairs. My other ordered pair is going to be 2009. And in 2009, I'm going to kind of see about where that looks to me. It looks like if this is 70, that this would be about 75,000, because you kind of have to estimate sometimes. So that would be how many, and I want to find the average rate of change, so which is the same as the slope. So I'm going to take 75,000 minus 20,000, And I'm going to divide that by the change in time, which was 2009 minus 2004. And when I do this, I'm going to have, looks like 55,000 over 5. And that's pretty easy to divide. I get 11,000, but I need some units for this. So I would say 11,000 digital cameras per year. And that would be my answer. Part B. We're doing the same thing for the average rate of change of the number of film cameras for those same years. So then in 2004, I need to know how many film cameras. Looks like there were 60,000. And in 2009, I know these years are so long ago for you guys, we had, if this is 30, that looks like about 35,000. And so my rate of change, I'm going to have 35,000, because that's the later time, minus 60,000 over 2009 minus 2004. So let me get this value. So we have a negative 25,000 over 5, which is negative 5,000 film cameras per year. So notice the negative, and part C asks us, what do the signs of each rate of change represent? Well, the digital cameras, notice that that is increasing. The amount of sales were increasing on the digital cameras, and at the same time period, notice the digital or the film cameras, the rate of change is it's decreasing. It has a negative slope. This has a positive slope. So that's the rate of change is going to show that as well. Okay, so these are the ones, these are kind of like non-thinking problems. There's no context to them. We're just using the formula to find the slope, but you know, we got to practice that. So for the first one, I'm going to have 12 minus 2 over 8 minus 3. I get 10/5, which I can say is just 2. So my slope is 2. For the next one, I already wrote the formula down. I'm not going to do that again. I get negative 8 minus 4 over 3 minus negative 1. Be really careful with your negatives. So I'm going to change this to adding the opposite in the denominator. Negative 8 minus 4 is negative 12 over a positive 4, so my slope is negative 3. By the way, if I drew a line through these 2 points, it would be going down from left to right. If I drew a line through these 2 points in number 4, it would be going up from left to right. So the slope tells us that. On the next one, my slope, I'm going to take 10 minus negative 5 over negative 7 minus negative 2. I'm going to change these to adding the opposite. So I get 15 over negative 5, which is negative 3. Again, on this one, if I connected these if I made a line through those 2 points, it's going to have a negative slope. And on these last two, we're determining the rate of change from the graph. So when you do that, I recommend you just find a couple of points that are on the grid points. So it looks like right here and right here. So you can do this a couple ways. You can either count, but it's a little tricky because of the scale. So if you want, you can think of this as the point 0, 20. And this point over here would be 20, 32. And then use the slope formula. So the slope would be 32 minus 20 over 20 minus 0. And I get 12 over 20, which would reduce to 3/5. And I would leave this. Don't change that to a decimal value because, I mean, you could. It wouldn't be wrong. But typically we would use that because this would tell us up 3 and over 5. And actually, because they did the scale the same, because this is scaled by 4s and this is also scaled by 4s, it actually would have worked. We could have gone up 3. Notice if you go up 3 and you go over 5, you get to the next point. So that actually would have worked as well because they did the same scale. On this one, notice the scale is not the same. So you can't just do the up and over part like we could have done here. So it's a good practice with the graph. So I'm going to write down the point 0, 10 as one of my points. And then it looks like this one I can use just the next point, which would be 1, 15. So then 15, to find the slope, I would take 15 minus 10 over 1 minus 0. So I get 5 over 1, or just 5 for my slope. Notice these don't have units. Like these problems, we needed units for those rates of change, but these we don't because we have no units. There's no context to these. So that should help you with some of the problems that you are going to be asked to do on your assignment.